Hi, in this video we are going to find how can we use balanced equation to find stoichiometry. And this video we are going to find the conversion from mole to mass or from mass to mass. Calculate the mass of aluminum oxide that can be produced from 21 grams of aluminum. So here we have mass and we need to calculate what mass. So we are moving from mass to mass. But here at the chemical equation, what is the coefficient? The coefficients of the balanced equation is 4 aluminum. They will form 2 aluminum oxide. So this is the moles fraction. So the moles relationship here is 4 to 2. We need to calculate the mass of aluminum oxide. So first of all, we have a given number which is 21 grams of what? Of aluminum. So if we have the grams, which is the mass, so we can calculate the molar mass to get what? To get the moles. So the first step is to calculate the molar mass. So the molar mass of aluminum, it will equal what? So let's calculate the molar mass together. So how many aluminum we have? We have only one, and this one has a mass which is 27. So 1 times 27, it will equal 27 also. So this is the molar mass of aluminum. Right, what about the moles? The moles of aluminum equal what? 21 grams, which is the mass, over 27 grams per mole, which is the molar mass. So 21 over 27 will equal 0.77, and this is the moles of aluminum. So these are the moles of aluminum. Now let's write this actual number of moles of aluminum and try to find out the moles to moles relationship. So we have 0.77 moles of aluminum. So from the actual number of moles of aluminum, let's find out how many actual moles of aluminum oxide has been produced. So 0.77 moles of Al that we have calculated times the moles fraction. Here we need to calculate the moles of Al2O3. So we will make the Al below here and the Al2O3 above at the fraction. We said that this coefficient equal the moles. So how many moles of aluminum we have? We have 4. So 4 moles of aluminum. And how many moles of aluminum oxide? We have 2 moles. So 2 moles of aluminum oxide. And let's time them together. So 0.77 times 2 over 4 equal 0.37. And these are the number of moles of what? Of Al2O3. So this is the second step at this type of questions. And we have the third step. So the third step here, we have the moles and we have the molar mass. We can get what? We can get the mass of aluminum oxide. So let's find together how to get the mass of aluminum oxide, and this is the last step at these type of questions. So if we have the moles and we need to calculate the mass, what is the rule that we are going to use? Moles equal mass over molar mass. So if we rearrange this equation, from this equation mass will equal what? Moles times molar mass. So mass equal moles times molar mass. And we have just calculated the moles, which is 0.37. So now we need to calculate what? The molar mass. So the molar mass of Al2O3, how many Al? We have 2. What is the mass of Al? It is 27. Plus, how many oxygens? We have 3. The mass of oxygen is 16. So 3 times 16. So let's calculate this molar mass and use it here at the equation. So from the given numbers, the moles are 0.37 as we calculated right now, times the molar mass, which is 74 grams. So the final answer here will be 37.74 grams, and this is the mass of Al2O3. Pause the video and try to solve this question by your own. After pausing the video, let's try to solve this question together. So calculate the grams of lead iodide that can be produced from 75 grams of potassium iodide. So we have two highlighted compounds, which is lead iodide and potassium iodide. So let's go to the equation, the balanced equation, and try to highlight them and try to do moles relationship. But here, do we have moles? No, we have grams. So from mass to mass, let's try to find out together how can we solve this type of questions. What is the given number here? The given number is 75 grams of what? Of potassium iodide. So we have mass of potassium iodide. We can divide this mass by the molar mass, so we can get what? So we can get the moles. So let's divide the mass over molar mass. Here we have the mass. How can we calculate the molar mass of potassium iodide? So how many potassium we have? 1. The mass of 1 is 39 plus how many iodide we have? 1. The mass of 1 iodide is 127. So what is the molar mass here? 39 plus 127, it will equal 166, and this is the molar mass of the following compound. So how can we measure the moles? Moles will equal, as we said, mass, which is 75 grams, over molar mass, which is 166 grams. So 75 over 166 equal 0.45 moles. So this is the number of moles of potassium iodide, Ki. So now we have the actual moles of Ki. We can do the moles relationship to find the moles of what? Of lead iodide. So let's do the mole fraction, the mole relationship. Let's type it together. So 0.45 moles of potassium iodide times the moles relationship. So what is the moles of Ki? It has only 2 moles of potassium iodide. This is from the balanced equation. So the moles fraction, that's the only information that we are going to get from the balanced equation. So 2 moles of iodide will cancel the moles of iodide, and on the top we are going to add the moles of lead iodide. So 1 mole of lead iodide, let's time them together. So 0.45 times half, it will equal 0.225. So these are the moles of BbI2, lead iodide. So now we have the moles of lead iodide. Can we calculate the molar mass to find the mass? Yes. So the mass, as we said, mass equal moles time molar mass. So if we have the moles, can we calculate the molar mass? Yes, we can. So let's calculate the molar mass together. Here we have the atomic masses of the following elements. So how can we calculate the molar mass of BbI2, lead iodide? So the molar mass here will equal, how many Bb we have? 1. The mass of lead is 207.2 plus how many iodide we have? 2. The mass of 1 iodide is 127. So this is the molar mass. So we have the moles from the previous example, which is 0.225. So the mass here will equal what? The mass here will equal the number of moles, which is 0.225 times the molar mass that we have calculated right now is 461.2 So if we time them together, they will equal 103.7 grams, and this is the mass of BbI2. This is the mass of lead iodide. Thank you for watching the video and see you next video.